Well, I had a look through my wood pile, stock of scrap wood, and I found this old bread cutting board, which I think will do just perfectly for mounting the little mini drill press. Now, these, you used to be able to get these from supermarkets real cheap years ago, and they're quite good wood. I've used this to, it's covered in all sorts of different holes because I've used it to mount various different steam plants and steam engines on over the years, but it'll clean up okay, and we can put some finishing oil on it. It'll come up quite nice. But sadly, you can still get these in different sizes from supermarkets over here in the UK, but they cost a bloody fortune now. I think I paid about a couple of quid for that years ago. Right, let's get the bits laid out on it then. Well, this power supply unit is the same one I used in my table saw build, and I've been using that for what, over a year now, probably nearly 2 years, and it's held up really well. So I think this came from eBay. That's a 755 motor from Banggood. I've made a bracket up to hold it using some bits of scrap aluminium I had in my scrap box. I'll move around the other side. There you can see the motor and the bracket in a little bit more detail. I intend to use the mill and slot these holes so that I can move this bracket backwards and forwards to allow tensioning on the belt. I think that should work out okay. So just got to get all that bolted down now. So machine out these into slots. I'm thinking about mounting a speed controller over here. I had one on order from Banggood, but I just received an email to say they're out of stock. It may take some time before it comes in, so I might have to rethink that. But at the very least, we can get it running at one speed once I've, got all the parts bolted down and the board finished off. So yeah, coming together nicely now. Well, I don't actually have the speed controller yet, but I've got the power supply mounted, and I've got a terminal block mounted, and the motor's all mounted and everything now. So I'm going to run it off a little bench power supply, as you can see there. Let's see the sort of setup that I've got. This will just allow me to run it and control the speed. Where obviously if I can't connect it directly to the main power supply, which is that little box there, because that's a 36 volt 9 amp power supply, and obviously I need to be able to vary that through a speed controller before using that. But we can run it off of the bench supply there, which I can control nice and easy. As you can see, oops, the motor's mounted now on its bracket, which has been painted. We've got the tooth belt on. It's all connected up. Let's come out again. Now, in the chuck, I have got a highly technical piece of kit, which is a round block of wood with a bit of reflective tape on it with a bolt through it. This is just so that I can accurately measure the speed that the thing's rotating at. Okay, let's get it running and see it in action. And there we go. That's 12 volts, just over. And that is giving us a speed of about 1300 RPM. That's cool. Let's wind it up a bit. That's 14 volts. That's given us 1560. I think I might possibly have the belt a little bit too loose. I might need to adjust that. And back down again. There's a bit of flap on the belt there. But it's definitely running very nicely. I'm quite pleased about that. Not too much vibration. yeah, I'm well pleased with that. Excellent success, it works. Okay, so all we need to do now is get the speed controller, wire that in so we can run it off of its own power supply. But for a first run, I mean, I know we haven't drilled anything yet with it, but I want to wait until we get its own power supply all wired in before we do that. But yeah, I'm well pleased with that. Well, I had rather hoped this would have been the last part of the video on the little drill press, and we'd be doing some drilling, but you know, the best laid plans and all that. The speed controller turned up, which you can see there. It's all wired in. I'll close in on it a bit. So this is the little speed controller box. Now, I've used one of these before. One of these is in my battery box that I use to power my power feeds for the lathe compound slide and the little Shoreline Mill X-axis. And they're only cheap Chinese ones. They work absolutely fine. This is the pot which you use to vary the speed. It's just a simple pulse width modulation speed controller. So I wired it all up. As you can see, that's why I put the terminal block in, so it allowed me to wire in the speed controller. I've got it disconnected from the power supply power at the moment. Turned it all on and absolutely nothing. It didn't do anything at all, which was not sort of what was expected. So I sort of checked all my wiring again, turned it back on again, and then it burst into life. And it was working. I could control the speed, and I thought, yay, we're there, all ready to go, you know, and let it run for a bit. And I was just about to turn it off and get the camera on it, and there was a loud pop, and it all died. So, quick investigation, I discovered that there's a little LED here on the power supply that had gone out. So, obviously, it was the power supply. And I'll show you what happened. We'll have a close look on the inside of the power supply. So here's inside the power supply. The board is actually loose, but it won't move very much because it's still wired in at this end. So I did a quick visual inspection of the power supply, and I found this. I don't know how well this will come out, but we'll have a look, see whether you can see this. I don't know whether you can see that, but all around the legs of these transistors here, there is some rather dark, smoky burn deposits on the PCB. Now these are the power output transistors, and I mean, they've obviously blown, but I really don't understand why that happened. Let's come back out again. Now those two power transistors are 2SC3320s, and that's a very, very common power transistor used in lots of different things. Fortunately, I can repair it. I think I can anyway. I've got a couple of replacement transistors off of eBay. But what I don't understand is why it went in the first place. This is a DC 36 volt 9 amp power supply. It's got really high capacity, and when we were running the drill press off of the bench power supply, we're only seeing a maximum of about 2 amps, I think was what we saw. So, you know, that's really nothing. You're almost drawing hardly any power out of the power supply. So it very definitely shouldn't have blown the power output transistors. So I don't really know what's going on there. What we'll do is, while we've got it all connected, I will power the whole lot up, including the speed controller, from the bench power supply. And that seems to work fine. So basically everything is exactly the same. I've just got, this would be the main power out from this, which is connected to the bench power supply. The ground is connected to the ground. Everything else is exactly the same. I've got this bench power supply set for 30 volts. And away we go, and we can increase the speed. And even in there, we're only drawing about 1 amp on the power supply, which is absolutely nothing. And even if we wind it up, 1.6 amps. So, you know, that's nothing. This power supply should be easily capable of supplying that, no problem. So why it blew, I just do not know. So I'm going to fix that, And then what I will probably do is put a fuse in the output line from the power supply to the speed controller, so it will be impossible for it to draw excessive current, and we'll see what happens when I do that. Okay, I've changed out the main two power transistors and the power supply is once again working. Hooray! So that was an easy fix. I have lashed in a fuse. It is not pretty, but it will do the job for the test purposes. It's pretty much the only thing. I need to get an inline fuse holder to do this properly, but to test this, there you go. So that's actually a PCB mounted fuse holder, but it's lashed in now in the main power line from the power supply to the speed controller. Now I've erred extremely on the side of caution, and that is a 3.15 amp anti-surge fuse in there. So it's only slightly over the kind of current we're currently drawing, but it should protect the power supply with a bit of luck. Now, while I was putting this all back together, a thought occurred to me, which may or may not have anything whatsoever to do with why it all went wrong in the first place. But I'm going to change the camera angle and show you. So we've closed in on the speed controller. Now, when I first had this lashed up, I had a bit of servo tape holding the speed controller to the side of the case of the power supply. And it did occur to me that maybe the problem was, I don't know what potential the case of the speed controller is, and this is almost certainly taken down to earth, the case of the power supply. And it may be that because the two were touching each other, as in metal to metal contact, that might have caused a problem. I don't know, it seems unlikely to me, but you never can tell. So what I've done is I've just put a thin bit of 3mm plywood in there so that this is now completely insulated from this. There's no metal to metal contact between the two of them. Whether that's going to make a difference, I don't know. But anyway, we're about ready to give it a go. Okay, fingers crossed, the big switch on. Well, that seems to be okay. I'm not going to run it up too fast. Because obviously we've only got a small fuse in there at the moment, but that seems to be all right. So I'll leave it running for a bit, just a few minutes. Check the case to see whether this is getting warm. That's where the power transistors are at this end of the case. The heat sinks are bolted onto this end. That's not even remotely warm. So that's a good sign, and it shouldn't be. I mean, we're not drawing, we're not even drawing a third of the current that power supply should be able to put out. Good. I think we're there. Let's turn it off. Okay. It appears to be okay. So now what I've got to do to finish it off is get a proper fuse holder in there and wire that in, and then we need a little plate to mount this pot on, and I also want to put a little digital voltmeter on here that monitors the voltage on the motor. That way I can write out a simple chart to say that X volts equals 1000 RPM, Y volts equals 1500 RPM, and so forth. So I've got so at least I can tell what the thing's doing at any given setting on the pot, basically, or at least in stepped increments on the pot. So onwards and upwards.